Hello friends, welcome back to my channel. Today I will discuss about what is INFEED and impact of INFEED in distance relay reach. So in order to understanding of the INFEED effect in distance relay reach, I have taken a simple example. So diagram shows the simple example containing 4 number of substation. Source is connected at substation A and substation D end, and there is a single circuit line in between substation A and B, and in between B and C, and in between B and D. The line length of all the line are equal for ease of understanding, that is 100 kilometer, and for ease of understanding I have considered that 100 kilometer line length is equal to 10 ohm impedance. Okay. So zone 1 for relay at this point at substation A for line section AB will be 80 kilometer, that is 80% of the line segment. So 80 kilometer or 8 ohm in terms of impedance. Zone 2 will be 120% of the line length, that is 120 kilometer, or in terms of impedance it will be 12 ohm. And zone 3 will be 120% of the line segment and next longest line. And next longest line is 100 kilometer. So zone 3 setting will be 240 kilometer in terms of line length or 24 ohm in terms of impedance. Now let us consider that fault occur at this point in between substation B and C. The fault point is located from 20 kilometer from substation B end. So in terms of distance from substation B end, it is 20 kilometer, or in terms of impedance it will be 2 ohm. Okay. So in first case I will discuss the impact of this fault point without INFEED. That is, this line is out of order. So there is no INFEED at substation B end. So in this case, we have considered that base MVA at 100 MVA, okay, and voltage level is 132 kV. So it is a 132 kV system I have shown. Now fault MVA at substation A end is 1000 MVA, and for substation D end also 1000 MVA. Since this line is switched off, so consider of this line is not required for calculation of fault current at this point. Since the fault MVA is 1000 MVA, we can easily calculate the source impedance for substation A. It is base MVA divided by fault MVA, which is 0.1 per unit. And Z base, since the voltage level is 132 kV, we can easily calculate the base impedance, which is equal to kV square divided by base MVA, which is equal to 132 square divided by 100, which is equal to 174.24 ohm. Now since the base impedance is known, we can calculate the per unit impedance for this line segment and also line segment up to the fault point from substation B end. So for line segment AB, the per unit impedance will be ZAB is equal to line impedance divided by base impedance, which is equal to 10 divided by 174.24, that is the base impedance, which is equal to 0.0574 ohm. And per unit impedance up to the fault point from substation B end, that is ZBF, equal to impedance, which is value equal to 2 divided by 174.24, which is equal to 0.01148 ohm. So here the per unit impedance for line segment has been shown, that is 0.0574 per unit, and for this up to fault point is 0.01148 per unit, and source impedance is 0.1 per unit. So total impedance up to fault point comes as Z source plus impedance of this line and up to the fault point, that is equal to 0.1 plus 0.0574 plus 0.01148, which is equal to 0.16888 per unit. So we can easily calculate the fault current, that is in terms of per unit value, which is equal to 1 divided by ZT, which is equal to 1 divided by 0.16888, which comes as 5.912 per unit. Okay. Now, since the base impedance value of the base kVA and value of the base uh, MVA is known, we can easily calculate the value of the base current, which is equal to base MVA divided by root 3 uh, into voltage level into 1000, which is equal to 437.4 ampere. So fault current in terms of ampere will be base base fault current in terms of power unit. So sorry, base current into per unit value of the fault current, which is equal to 5.912 into 437.4, which is equal to 2.586 kiloampere. So here the fault current is 2.586 kiloampere. So we can easily calculate the value of the voltage at relaying point, that is VRA, which is equal to 2.586 into 10 impedance of the line segment AB plus fault current up to the fault point, that is 2.586 into the impedance up to fault point from substation B end, which is equal to 2. So the value of VRA is equal to 2.586 into 12 kV. And current sensed by the relay in terms of the primary value, that is IRA, is equal to 2.586 kiloampere. So ZRA, impedance seen by the relay, that is ZRA, is equal to voltage divided by current, which comes as 12 ohm. In terms of impedance or in terms of kilometer, the relay will see this fault current at a distance 120 kilometer from substation A end. Now case 2. Now consider that fault occur at a distance 20 kilometer, that is same distance from substation B end, and line BC is exist with same infeed. The source fault MVA at substation D end is 1000 MVA, which is equal to the fault MVA at substation A end. Okay. So in this case, we'll calculate the infeed effect in distance relay reach. So since the base MVA is 100 MVA and voltage level is 132 kV, ZSA, that is the source impedance at substation end, is equal to base impedance divided by fault MVA, which is equal to 0.1 per unit, and ZSD, which is the value of the source impedance at substation D end, which is equal to 100 divided by 1000. 1000 is the fault MVA, which is same, that is 0.1 per unit. Since the fault level of both the substation source is same. Okay, and Z base is 132 square divided by 100, that is the value of the base MVA, which is equal to 174.24 ohm. ZAB, that is the impedance of the line segment, is equal to 0.0574 per unit, which already calculated in case 1, and ZDB, which is equal that to ZAB, which is equal to 0.0574 per unit, since the line length of both the section is same. And ZBF, that is impedance of this line up to relaying point, is 0.01148 per unit. Now ZA is equal to ZSA, that is the source impedance at substation A end, plus ZAB, which is equal to 0.1 plus 0.0574 equal to 0.1574 per unit. Now ZD is equal to source impedance at substation D end plus ZDB, which is equal to 0.1 plus 0.0574, which is equal to again same, that is 0.1574 per unit. Now ZBF is equal to 0.01148 per unit. Now total impedance, that is ZT, equal to parallel combination of ZA, ZD plus ZBF. So this total impedance comes as 0.09018 per unit. So we can calculate the value of the fault current in terms of per unit, which is IF per unit equal to 1 divided by 0.09018, which comes as 11.088 per unit. Now base current is 437.4 ampere. So value of the fault current will be base current into fault current in terms of per unit value, which is equal to 11.088 into 437.4, which comes as 4.85 kiloampere. Now value of the ZA and ZD equal, which is 0.1574 per unit, and fault current is 4.85 kiloampere. So the fault current supplied by substation A and substation D will be equal, since the value of ZA and ZD equal, which is equal to 2.425 kiloampere. So same fault current will be supplied to the fault point from substation D end and also from the substation A end. Okay. Now we can calculate the voltage C at the relaying point at substation A end, that is VRA, which is equal to fault current sensed by the relay, which is 2.425 kiloampere into impedance of this line segment, that is 10, plus total current, that is a fault current IF. Value of the IF is equal to 4.85 into impedance of 2 fault point from substation B, which is 2. So VRA comes as 33.95 kV, and IRA, that is the fault current sensed by the relay at substation A end, which is equal to 2.425 kiloampere in terms of primary value. So impedance sensed by the relay, ZRA, equal to voltage divided by current, which is equal to 3.95 divided by 2.425, which comes as 40 ohm. In terms of impedance or in terms of kilometer, it will be 140 kilometer. Although fault occur at a distance from substation A end 120 kilometer, relay will see this fault at a distance 140 kilometer from substation A end due to INFEED from substation D end. Now case 3. Now let us consider that fault occur at the same point, that is from substation B end 20 kilometer length, but with strong INFEED from substation D end. Here the source fault level of the source at substation D end is considered as 5000 MVA. Now since the base MVA is 100 MVA, voltage level is 132 kV, ZSA, that is the source impedance of substation A will be same, that is 0.1 per unit. Now ZSD will be changed here. It will be value of the base MVA divided by fault MVA, which comes as 0.02 per unit. Now ZB, that is the base impedance, which is equal to 174.24 ohm. Now ZAB is same, that is 0.0574 per unit, and ZDB is same, that is 0.0574 per unit, and ZBF also same, that is 0.01148 per unit. Now value of the ZA is equal to ZSA plus ZAB, which is equal to 0.1574 per unit. Now value of ZD will be changed. Since the source impedance has been changed, it will be ZSD plus ZDB, which is equal to 0.02 plus 0.0574, which comes as 0.0774 per unit. Now ZBF is same, that is 0.01148 per unit. Equivalent impedance seen by equivalent impedance at fault point, which will be equal to parallel combination of ZA and ZD plus ZBF. which comes as 0.06336 per unit. So we can calculate the value of the fault current in terms of per unit, which comes as 1 divided by equivalent impedance or total impedance, that is 0.06336, which comes as 15.7829 per unit. Now, since the base current is 437.4 ampere, fault current will be 15.7829 into 437.4, which comes as 6.903 kiloampere. Now, since ZA equal to 0.1574 per unit and ZD is equal to 0.0774 per unit, so fault current contribution from substation A end will be fault current into ZD divided by ZA plus ZD, which is equal to 2.2755 kiloampere. And fault current feed from substation D end, which will be equal to fault current into ZA divided by ZA plus ZD, which comes as 4.6275 kiloampere. Okay, so 2.2755 kiloampere will be supplied from substation A end via this line, and 4.6275 kiloampere will be supplied from substation D end. Total fault current is 6.903 kiloampere. So we can easily calculate the value of the voltage at relay point, that is VRA is equal to 2.2755 into line segment impedance, that is 10, plus 6.903 into impedance of this segment line, that is 2. So which comes as 36.561 kV. Now fault current sensed by the relay is equal to 2.2755 kiloampere. All the fault current, actual fault current up to fault point is 6.903 kiloampere. So impedance sensed by the relay, that is ZRA, will be voltage divided by current, which is equal to 36.56 divided 61 divided by 2.2755, which comes as 16.06 ohm in terms of impedance value, or in terms of kilometer it will be 160.6 kilometer. Now fault occur at a point 120 kilometer from substation A end in the line segment BC. Since there is a strong source in substation D end, due to INFEED effect, the fault sensed by the relay will be 160 kilometer. So relay will underreach due to strong INFEED effect.